Hey, Purple Group. So obviously you guys have figured out, or maybe are going to figure out, that you are Purple Group. So we're going to be looking at lesson 3.5 traits today. And your learning target is I can describe how multiple genes can affect a single trait. So oftentimes when we study things in genetics, we look at really simple things, especially for you guys in 7th grade. But in real life, oftentimes a certain trait that we see is affected by more than one gene. Okay, so let's double check really quick that you are in fact Purple Group. So what you will need to do is right click and open this link, and this should show up for you guys. If you are indeed Purple Group, you will see Purple Group when you open that link. If you see something else, obviously you're not Purple Group and you need to exit out and go into the correct color for this video. All right, so you already found your videos for each group. Again, you are Purple Group. So in this table, it tells you guys you are only completing slides 16 through 21. So you guys can see that your slides are color coordinated. Here's Blue Group, Green Group, and here you guys are at Purple Group. So starting on 16, your guys' magic color of the day is pink. So anywhere you see either pink font or this hot pink question mark, that is something that you guys need to fill out and do. So this is a slide that's something that we need to answer questions on. All right, so to start you guys off on your first activity, which is your warm-up today, you guys have these two diagrams in front of you. Again, those diagrams are probably focusing on more than one trait a trait being influenced by more than one gene. So what I want you to do is look at the two diagrams and then add a caption under each of the diagrams, just kind of summarizing what the diagram shows. It may be what you learned from the diagram, or what you guys would tell someone else if you were maybe trying to explain the diagram to them, or just kind of describing what the diagram says. So your first diagram looks at one organism with two sets of genes. So here's two chromosomes, one from mom, one from dad. They have the H1 allele for both, and they produce this protein, okay? Different set of chromosomes with different genes. We have P1 and P1. Again, homozygous, where both parents pass on the P1, makes this protein, and together both of these protein molecules affect the hair texture. So most traits are created through the interaction of many kinds of protein molecules. For example, and remember that protein molecules have a specific shape, and it's that shape that kind of dictates what they do. So for example, hair texture is affected by two types of proteins. The proteins that affect hair texture include those that actually make up hair, as well as those that affect the shape of the pore, the hole in where each strand of hair grows from. Each separate gene is an instruction for making a specific kind of protein molecule. Okay, so tell me what that diagram means to you, whether you're summarizing it, explaining it to someone else, or telling me what you learned from it. Okay, the second one, we have female parent genes and then male parent genes. So it looks like we have two different chromosomes with two different sets of genes. So mom, for one of those sets of genes, has H2H1, and for the other set is P1P1. So these are two completely different genes. They may not even be on the same chromosome. Okay, versus dad has H2H3 and P1P2. Okay, so we can look at all the possible gene combinations. Looks like there's 8 of them. So if these two parents were to have offspring, they could be any combination of those below. So that's quite complicated to get. Normally you kind of have 4 different combinations. When a trait is affected by many genes, a number of possible gene combinations for offspring significantly increases. So you guys can kind of remember where we did predictions of, all right, if Zora the spider passed this down, what might Greg the dad pass down, and what are their different possible combinations of offspring? We typically only had 4. Okay, now we see 8. So by adding the different number of chromosomes, we've almost doubled the different offspring. Okay, so add your captions to both of those. Moving on to the next slide, which also has a big pink question mark. You're going to answer this question about those two diagrams. So sometimes a trait is not determined by just one gene. The diagrams above show that multiple genes can affect a trait. What does it mean when multiple genes determine a trait? List your ideas below. So just kind of tell me some of your thoughts about that. All right, moving on to your next activity. It's a simulation. You guys have your instructions right here for the simulation, and your simulation link is right here, so you can click on it, right-click it, and open that link, and it takes you right into the sim. Okay, so you're going to select Greg, choose size, and observe Greg's trait. So up until this point, we've kind of avoided looking at body size because obviously that was meant for you guys in the Purple Group who are looking at multiple genes and how they might affect a trait. So let's go ahead, choose Greg, And let's go ahead and change him to body size right here. So what we see is we have two different sets of proteins, and then for each of those sets we have two different types of proteins. So we can see set A must be one gene that we're looking at. So here we go. Greg has A2A2. And for his second set of genes, he has B2B2. So he can either make, so for his first protein, he's going to make the 2, which is this guy right here. And then for his second chromosome, looks like genes on a different chromosome entirely, you have B2. So he's making this weird kind of oval shape with the nick taken off. And that is what is giving him this small body size. Okay, so what you guys are going to do is follow your instructions for that. It says choose, size, and observe Greg's traits. Attempt to change Greg's genes so that he has the trait for medium body size. So you guys are going to go up here and tweak these different alleles and try to get him to have a medium body size. Okay, then answer these questions here. What did you notice about the genes and proteins that determine the traits for size? Okay, so obviously there's multiple genes that do this, and there's different traits for size that he can have. Okay, question 2, observe Otis's and Ruby's traits and genes for size. So now you're going to need to pull in Ruby and see kind of what her body size is and how those different proteins have created that size. So she's A1, A2, B1, B2. So she has a little bit more variation than Greg did. So she has this protein too. She has A1, she should have a little U-shaped protein. There's one right there. And then B1, B2, again, she should have both of these proteins as well. So here's that kind of little mushroom shape. Oh, look, they kind of connected to this little U-shape. And then this little guy right here, this little half circle, maybe we'll see them kind of interact. You guys watch for a little bit. So observe Otis and Ruby's traits for size and genes, and then Ruby was medium. Okay, so you guys, if you haven't figured it out already, you know now kind of how you can get medium for Greg. What size do you think their offspring will be? So if Ruby was medium and Otis was small, maybe make a prediction about what you guys think their offspring will be, and then mate them and actually test it. So mate Otis and Ruby, were their offsprings all the same size? What did you notice about the body size gene combinations of the offspring? And then finally, we have 13 different clotting factors for protein in our blood. So we learned about this last week when we read about hemophilia. Do you think hemophilia is controlled by one or multiple genes? Okay, so answer that question. And then moving on, you guys have a little reading right here. So read about different diseases that can be caused by multiple genes and then answer this question. If a disease is controlled by more than one gene, will there be fewer, greater, or the same number of possible gene versions that offspring can inherit from their parents? Explain your answer below. So think about what you guys saw in that simulation with Ruby and Greg, I believe. Okay. Finally, slide 21 is your wrap up. You guys do need to do this. It takes about 2 seconds. It's not that hard. Do you have any questions? Circle yes or no. If you have any questions, please type them in here and I can get back to you on that. Obviously, if it's something that's preventing you from completing the assignment, you want to send those questions right away in Teams and I can help you out. And then finally, circle 4, 3, 2, 1, ranking how you feel you did on this. Okay, once you are all done with this assignment, go ahead and turn it in, and I hope you all are having a great day. I'll talk to you soon. Bye.